guys feeling? Mixed reactions, fair. So, test week starts today. Some of you might take it this afternoon. You are allowed to take it a different day. You don't have to attend your normal lab day. You just have to be able to fit it in your schedule. But I have some people voluntarily taking it on Monday just to get it over with. So, main goal for today and also for this week is just answering questions from you guys, making sure everyone feels comfortable with the test. So, and that's, it is Monday and I forgot how to talk. What is on your minds? How's the homework or practice test been going?
I do have a question about something.
Okay.
I think it's still in here on the door.
This one?
Yeah.
All right. So here we have projectile motion. You're going to launch a cannonball off of a cliff at a 45-degree angle. It's going to move up. Its initial speed points up, and it's up and out. So it has two different x, well, technically the same x versus y component, but that only happens at 45 degrees. And then the y has to be used in the vertical equation to determine hang time. X is used horizontally to determine range. What's on your mind?
I guess after I find like the components of like the initial velocity, it's just my main problem is finding which equation to use.
Okay. So,
For questions like this, do we always need to solve for like time first?
well,
Or is there another way to do it?
let me kind of try to describe like my thought process as I would work through a question like this.
Okay.
So in this scenario, we're launching something off of a cliff. By virtue of it being a projectile, it is falling the entire time, even as it technically moves upwards. And because it is falling, its acceleration is automatically negative 9.8 in the y-axis. So this automatically becomes true. Gravity accelerating in the y and no x acceleration, because a falling object, a projectile, is only accelerating down because of gravity. If it's accelerating in the x, it's technically not flying, it is possibly gliding or maybe flying. So, when the question says, when the question implies projectile, because cannonballs don't usually have rockets, this automatically becomes true, and that makes it a projectile motion question. And that means that the object is moving, displacing, while accelerating. There is an acceleration taking place, and we've been asked about its motion. So the end goal here is the range. How far from the base of the building does the cannonball hit the ground? And that displacement would be delta x. So, you know what? Let me write down like I was doing this in full as a class example. Initial velocity was 25 meters per second. That gets divided up into components. Starting height, so y initial, is 30 meters. We've been asked for delta x, and because we are falling, the acceleration is 0 in the x and negative 9.8 in the y. So the text doesn't state this number, but it is implied by being a projectile. So that is the information that we've been given. We want to know delta x, the horizontal displacement. And since that is displacement, we would look at our formula sheet for the equations that have delta x in them. I see, well, let's look at all three. Let's look at all three of the first four equations that contain displacement. First is constant velocity equals delta x over delta t. Next is delta x equals initial x velocity times time plus 1/2 times x acceleration times time squared. And then lastly, there is another one that has delta x in it. Vf squared equals v initial squared plus 2 times a times displacement. So all three of these have displacement in them. Delta looks weirdly rounded. There we go. And frankly, two of them would get the job done in this particular case. Formula number 1 and formula number 3 would both be good picks because they talk about displacement as a function of the velocity that the object is currently moving in the x-axis at. Both are equally valid here, specifically because the x acceleration is 0. Because this formula only works when you're not accelerating. That's the big caveat asterisk I recommended writing on your formula sheet. This one works when you're not accelerating. And that is actually true in the x-axis here. And technically this formula would accomplish the same thing because if x acceleration is 0, that whole back term just goes away, and what you're left with is technically formula 1 again, just pre-solved for delta x. So 1 or 3 get the job done here. 4 kind of falls apart because if x acceleration is 0, that kills the term you wanted. So this one's out. And that leaves technically the same formula twice. But either way, we need time. We need another formula to tell us the hang time of the projectile. And typically on planet Earth, the vertical axis has more control over hang time than the x-axis does. And given that objects always have a constant vertical acceleration, the vertical axis just tends to be a better indicator of when something will hit the ground. The height you drop something at is the sole determinant if you're just dropping something. But here we're not just dropping it, we're also launching it partially upwards. So we would separately need to analyze the vertical axis to figure out hang time. And so that's kind of where the axis split ends up coming from. If you just started by wanting to find delta x, you would arrive at the conclusion that you need time, you need some way to determine time. And so I would then recommend running through the formulas again to figure out which one works for determining time. And of the 4, there's really only one option. Because formula 1 doesn't work in the vertical axis because acceleration doesn't equal 0. And formula 4 doesn't have t in it. That just leaves formula 2 and 3. They both contain t's. In this one though, you do know the y acceleration, but you don't know the change in its velocity, because this one's very specifically change in velocity. So you would need more information to find t. Actually, I guess you could use formula 4 to find final velocity, then use this one. So that's technically an option. But formula 3 is my formula of choice for this because you do know the y displacement. You can find your y component of initial velocity. It has t's in it, and we also know what the y acceleration is. So time is the only thing after you find initial y speed. Time is the only unknown left in here. So this one equation does get you there, but it does require the use of a quadratic. But technically, I hadn't actually thought to do this in a minute. Initial velocity, acceleration, delta y. Yeah, you could use this to find, you could use Formula 4 to find final speed, plug it in here with initial speed and gravity, and that'd be another way to find hang time, actually. So you can technically avoid a quadratic here. Oh, why'd my computer do that? So you do not have to automatically jump to Formula 3 and 2 axes at once. There is, at least in my opinion, kind of a logical flow to arrive at that conclusion. Does that help address your concerns? Okay. That's also why you should never feel bad if you look at one of these questions and don't immediately know what to do. Because physics is hard. Each question is its own weird, unique logic puzzle, if I'm being honest with you. On the test, it is totally valid to read a question a few times and then just start writing. Like, go through this process of writing what you know, put down what formulas might be useful. If you're drawing a blank, you can always ask me or Dr. Edwards a question, because we want to make sure you understand what's being asked of you. We want to make sure you understand the question, the prompt, what your objectives are. And once you go through this step of putting down variables and formulas, it's okay to just kind of play with them for a minute. Like, think which ones might be useful, see if they lead anywhere. If they don't erase it, because again, I give you points for everything you write. You should only erase something if you need more room on your paper. And even then, I'd be fine if you used scratch paper and handed that in with your test. And even if after all of that, even if this does not jumpstart a good logical process, you're allowed to just write sentences about what's going on. Because what I'm really looking for is your conceptual understanding. Like, getting the final numerical answer is required for an A+, but I still want to see what you understand, even if you don't understand all of it, even if you can't get to a correct numerical answer. So if you are stumped after doing all of this, again, I highly recommend variables and formulas, because the way I create my grading keys, you get points for just writing down the formulas you need. In this specific question, writing down formula 3 once is like half the points. Half the points that I've already assigned. If someone does something unexpected, I figure out a different rubric for their version of it. But even if after, again, all that, you're not sure how to proceed with the math, try to get an answer, and again, just tell me what you understand about it. Like, in this scenario, you tell me you understand it's a projectile. It's accelerating in the y-axis, it's moving in 2 axes at once, anything that comes to mind. Just because I'm looking for math doesn't mean I won't give you points for a written summary. Any answer is better than no answer, even if the answer you give is a frowny face. Because it's an answer, it's just not a good one. Like, you get 1 out of 10. If it was a frowny face and nothing else. So technically, if you write frowny faces for every question, you get a 10 out of 100. And that's if you wrote literally nothing else. Again, the only way to get a 0 is to leave it blank. Or I guess don't show up and never do it. First of all, does that answer your questions about this one? Mm-hmm. All right. What else is on your minds?
I just have like 2 more questions.
Okay.
So know there wouldn't be like much force, well, any force in the Y since it's not like going up, but wouldn't there be force in like the X direction?
So the key that the net force in all directions should be 0 is this bit right here, constant velocity. If your velocity isn't changing, what is your acceleration?
0.
And if your acceleration is 0, Newton's second law tells you that net force is 0. So what that means about all the forces here is that they must be adding up to 0. So the first question is, what is the net force? If it's at constant speed, net force must be 0. Part B is identifying the 4 forces that must be here. And then part C is figuring out what they all must be equal to, such that they all add up to 0.
So if the question doesn't like mention that there's no friction, do we assume that there's friction?
Oh. Typically, well, okay. I will try to mention if there's friction. Let me actually, again, I want to be as non-vague as possible, so let me actually read my own test questions real quick. Okay, any question that involves friction, I have mentioned it is present. Now, in this question, my intent was to imply that there's friction because the rope, since the rope's at an angle, so it's whatever force, oh, well, it's 100 newtons divided up into 2 legs. One of those legs points forward in the x-axis, which means that there has to be something pushing backwards to negate that. And even though snow is very slick, it does leave some friction behind. So here, net force x-axis, we've got rope forwards, friction backwards. It has to be there to negate the force forwards and cancel out to 0. Something has to be there. Also, I do realize that in an early draft of the practice questions, I didn't mention the mass of the sled. I did fix that, but if you downloaded the practice test early, as I did here when I made my answer key, I added, okay, if you downloaded it early, this is just, the mass is just missing. If you've downloaded it more recently, I have added that the mass of the sled is 25 kilograms. If your version doesn't say that and you're working on it, assume the mass of the sled is 25 kilograms.
Can you explain how you got the moving force for this problem?
Yes. Normal force is the one I figured out last. Wait. Did I not show that math? Oops. Well, that means I wrote an incomplete answer key, and I apologize. You know what? I started it, and then I must have got distracted by my phone ringing or something. And then when I came back to it, I figured, oh, it's done, and I moved on. So that's my fault. So this was net force in the x-axis. I figured out normal force by doing net force in the y. So, this marker's terrible. Is this legible?
Yeah.
Okay. Net force y. We've got normal force up, whatever it is, gravity down, and also the y component of the rope up. Since the rope is at an angle, you are kind of pulling up on it, partially. So all 3 of those things are present vertically, and as with the x-axis adding up to 0, so too must the y for this thing to not be either rising or falling. So all 3 of these things must add up to 0. Normally, on a flat surface, normal force and gravity tend to be equal and opposite, but that's not the case here. Since this person is pulling up, they're actually kind of reducing the burden of normal force from the ground. Kind of like, again, if you are standing on a bathroom scale and you use the counter to partially lift yourself upwards, the scales, the weight it reads decreases because all the scale tells you is the normal force it exerts on you. It doesn't actually know, how much mass is in your body. So this is partially lifting the box, reducing the normal force, and that's why I would recommend in this type of question saving normal force for last, because to find it, you need to know what gravity is, which you can find with Fg equals mg, and what the y component of the rope force is, which I derived using trig up there. So n minus 245, that's the weight of the object, and plus 70.7 equals 0. Therefore, normal force should equal, if we send both of these over, 245 minus 70.7. Therefore, normal force equals 174.3 up. Not quite not quite equal to the weight, but still opposite. If the rope was only pointing sideways, then that y components of the rope wouldn't exist and normal force would be opposite to gravity. But that's only if the pair of them are the only vertical forces present. How's this one go?
Will the force of gravity always be like negative?
It should, yes. Like the way that I like to set up my equations, g is a negative number, gravity should always be negative, just meaning down. Like WebAssign might ask you occasionally for the magnitude of gravity, in which case it wouldn't be looking for a negative sign. But in my perspective, it's always negative because it's a vector that points down. And I have written my test questions as such. What else is on your minds?
I have like a question about number 5, because I tried to solve it by making the tensions like equal each other by solving for 2 different equations. Like the math got confusing because I made like.
Well, the two t's do end up being the same number eventually. Now what I did here is, from the flower pot's perspective, there were both x and y forces acting on it, so I looked at net force in both the x and the y axis. What do those net forces need to be for this flower pot to remain tied in place? 0. So there's another, constant not moving is also constant velocity. Therefore, the net forces must be 0 no matter what is comprising them. So one of the first things I did was look at the net force in each axis. In the x-axis, there's the x components of the two tensions that must be equal and opposite and add up to 0. In the y-axis, the two y components of the two tensions both point up, where gravity points down. So in the x-axis, the ropes work against each other, and in the y-axis, they work together to overcome gravity. So again, these are the forces acting upon the flower pot. Now technically, if we consider gravity to be known, because we have the weight, the mass of the flower pot, that still leaves 4 unknowns in terms of the components of the 2 vectors. So all this work over here is the trig to divide them up into their hypothetical components. We don't have numbers for T1 or T2, but we can still determine a ratio of how much of the unknown tension ends up in each axis. So I labeled this one T1 because I'm left-handed and I work from left to right. T1, its y component would be T1 times sine of 60, its x component would be T1 times the cosine of 60, and because tension 2 points at the same angle, it would actually have the same ratios, just mirrored. Which really just means that the x components point against each other, but the y's still both point up. So this process was taking the 4 unknowns, the legs, and reducing that down to 2 unknowns. Now all of them contain either T1 or T2. And then by plugging those in over here, that would reduce the number of unknowns in these equations by trying to make it all about T1 and T2 rather than about their legs. Questions so far? Now what happens next is technically a 2 equations, 2 unknowns scenario, as tends to happen with these ropes pointing in numerous directions cases. It's just kind of an odd version of it. Because looking at the x-axis, the 2 x legs must add up to 0, and by plugging in the divvied up vectors from over here, again, the x leg of T2 must be T2 cos 60. So, like normally if we had T2, this is how we would find a number for T2x, but we don't have a number for it, so we're just gonna leave it like this. T2x becomes T2 cos 60, T1x is T1 cos 60, but they point in opposite directions, so I made one of them negative. If one of them's negative, I then sent the negative one over to the other side, and that gives T2 cos 60 equals T1 cos 60, and a weird thing happens since the angles match. The cosines just kind of cancel out. So in this case, what the x-axis is telling us is whatever T1 and T2 are, they're the same number. And so this is technically 2 equations, 2 unknowns. It's just the second equation, well, the first equation told us the 2 things we're looking for are the same thing. And you can then take that and kind of reduce the number of unknowns further down because, well, now it's not really T1 versus T2, it's just what is the one T that they are both equal to. So down here, this is the y-axis version. Fg is the weight, so mass of 10 kilograms times negative 9.8. The y legs are the respective full tension times the sine of 60, but since T1 is T2, I just kind of eliminated T1 or T2 and just wrote T. Because, again, we've determined that they're the same thing. So, working forward from here, this would become negative 98, I send it over to the other side. These would add up into 2 times T times sine of 60, so divide both sides by 2, divide both sides by sine 60, and both T's should have a magnitude of 56.6. That wound up being the same number because they are just mirrors of one another. If they were different angles, like the one we did in class were, they wouldn't quite cancel out like that, or they wouldn't be the same thing. But here, it worked out that way. Excuse me. How does this one feel?
Cool.
Could we solve for like T1 and then from both equations and then equal each other to find T2 if we know both tensions are the same? Or would that not work?
No, that would work. Like say instead of making them both the same T, now I've written all over myself. Say that I kept the T1 and the T2, rather than me skipping a few steps because I know they're the same thing. This one simplified down to just T2 equals T1. So you can still think of this as the second equation with the same two unknowns in it. We can divide both sides by sine 60. That would give us T1 plus T2 equals 98 over sine 60. You could, say, solve this for T2. So T2 equals 98 over sine of 60 minus T1. And T2 equals this. T2 also equals T1, which means if we did set these equal to one another, it'd be T1 equals T2 equals 98 over sine 60 minus T1. We cut the middle part out, and that would be T1 equals 98 sine of 60 minus T1. We want all the T1s together on one side, so we'll add this one back over. That would be T1 plus T1, which is just 2 times T1, 98 sine 60. And so we take this fraction and further divide it by 2. So this is technically 2 equations, 2 unknowns. It's just the 2 unknowns are the same thing. Does that help with this one? How do you guys feel? At least one thumbs up, or rather 2 from the same person. Anything else on your minds for right now? You are also allowed to ask, you don't have to ask questions about, the practice test or review homework questions you've been doing. You can ask anything you're wondering or worried about. But you can also ask nothing if you don't want to, because there's sometimes just merit in resting. So if there's nothing else in your minds, we can call the lecture and you guys can just take a brain break. Or if you want, I can just say things that I think are helpful. I'm trying to think of things I haven't mentioned yet. At least a few people nodded to that one, so let's see. What is helpful that I haven't already mentioned? Or possibly that I have mentioned and feel should be restated. I'm talking to myself at this point. Let's see. I believe I told you to do this already, but if you haven't, you should totally write this triangle on your formula sheet. in reference to the angles of normal force, gravity, and friction if something is sitting still on an incline. When I was a physics major at this school, it took me at least a year of being a physics major before I could reliably turn this into this by myself without that picture. For that reason, I again recommend write this on your formula sheet. Because my biggest struggle with this when I was a student was trying to remember where that 30 degrees needs to go. Because I was always wrong about that. I guarantee to, I'm treating this as basically a formula in its own right. This is a tool that I am giving you to be able to use. All of your formulas are tools, and it's up to you for any given question to decide whether to use your wrench or your hammer. This particular wrench specifically exists to remind you of the angle between normal force and gravity on when an object is sitting on an incline. And I promise you that this angle here is the angle of the incline. In this particular question, it's 30 twice. Sometimes when I put it on the board, I put theta in both, and I mean it is the same theta twice. I don't just write theta because that's just the letter for angles. It's because it's the same angle. And again, my hurdle was always, well, why is that the 30? Why? And it's because the angle of the incline is always, by definition, the same as the angle between normal force and gravity. And that is technically even true on flat ground. Right now, if normal force points up and gravity points down, what is the angle between normal force and gravity in this picture? It's 0. They're totally equal to each other. There isn't an angle between them. If I tried to draw these two vectors tip to tail, I drag it up and they overlap. They're totally parallel. There is a 0 degree angle between them. And likewise, what is the angle of the slope of this terrain? 0. So the rule technically is still holding here. The angle between normal force and gravity is the same as the angle of the incline. If one is 0, the other is 0. And then things start changing as you begin tilting. At a very shallow angle, the markers are all dying. At a very shallow angle, it would look something like this. And really what this picture comes from is me just taking all of these vectors and not even rotating them, just dragging them over and arranging them tip to tail, and they happen to form a right triangle. So they're all pointing in the same direction. I just physically click and drag them over here. So to do the same thing here, I'm going to physically take this gravity line and drag it up here to draw it tip to tail with the normal force line. It just points straight down. Notice, here we have a very shallow angle, like the incline, as opposed to what happens at a very steep angle. Because at a steep angle, like super steep, like 70 degrees, normal force almost doesn't exist. It's almost pointing straight horizontal. So it's got a very big angle between it and gravity. Eventually, if you get all the way up to just a 90-degree wall, normal force just kind of vanishes. So not only is it constantly changing direction, it's getting weaker as you do this. And again, it just goes away 90 degrees. So, this is my quick rant about how and why these angles, the angle between normal force and gravity, is the same as that of the slope. If that triangle ever doesn't make sense, I always visually compare it to these two extremes. I find in general, if a concept doesn't make sense, try thinking of examples of it in the most extreme cases. So, have that on your formula sheet. This triangle specifically has static friction here because it's meant to represent how all these forces are adding up to 0 if the object is sitting still on the incline, like friction is strong enough to just hold it in place. And this particularly will be a very useful version to have on the test, cough, cough. And all of those vectors are the same as the vectors as on the free body diagram. Normal force points out, perpendicular, gravity points down, friction points along the slope, specifically in the opposite direction that the box would be sliding if it could. Friction always opposes motion, and objects on ramp tend to slide down the ramp. As a result, the friction is going to point up, and that's why it's still pointing up when I drag it over here. And curiously, gravity is always the hypotenuse of this triangle because the normal force and the friction, by definition of normal force, have to be perpendicular to one another. So the right angle ends up there, and the hypotenuse is always opposite the right angle. So it's not drawn like a standard right triangle, but gravity is the hypotenuse. So that would be one tip that comes to mind. Let me see. I think that's the main thing I haven't mentioned out loud. How do you guys feel? There's 2 thumbs up, not counting my own. So, I will point out again, you are allowed to ask questions during the test, and that's true of whoever's proctoring it, me or Dr. Edwards, because he is proctoring the Monday and Tuesday ones, like he does for lab. I encourage you to ask questions if you're stumped, because I want to make sure that you understand what is being asked of you. Like, if you are not sure quite exactly what is being asked of you or what you're supposed to find, he or I will make that clear. Because I don't want you to get stumped because I worded something in a way that you would not think to read it. I've tried to make it as clear as possible, but you know, I'm a different person to you. We have different thought processes. So ask questions, have answers for everything, show as much math as you can, and also don't be afraid to just write sentences if you're stumped. Don't leave anything blank. I also leave like little boxes for you to put your answers in, just so that it's easier for me to find them and create it quickly. So I appreciate it if the answer is in that box. It makes my job go quicker. It's usually located at the bottom left of whatever space is allotted for a given question. There is 105 points graded out of 100. So there is more than enough points, more than the points you need to get an A+. Bonus points are built in. Bring your formula sheet, bring a calculator that isn't your cell phone. You are allowed to take breaks and pause, because you've got the whole lab period to take a 1-hour test. So you can technically take a 2-hour nap if you wanted to. This isn't these desks are the coziest place for it, but you know what you need better than I do. Now, I wouldn't say, you can't just stop and pull out your phone for a break, but you can just put the test down, close your eyes and breathe, like, and go to the bathroom and get water. You don't have to just book it all the way through. You've got, test is written for 3 hours. Wow, no, rewind. Test is written for 1 hour, you have 3. And if you also need if you have any academic accommodations on file, they will be met, but you'll have to remind Dr. Edwards and I, because we don't have them all memorized. We have other rooms, and the time has already been allotted for by giving you the 3 hours. I think that's everything. And I apologize for saying the same things repeatedly over the past month, but I forget which section I've said what things to most directly. So do this 3 times a day. Anything else in your minds right now? All right. Let me know any questions you have while studying, either the homework, the quizzes, or the practice sheets, practice test. Remember again, you can take it any of the 4 lab days this week. Thursday is the only day that doesn't happen. Thursday is a myth, and I'm just rambling at this point. Please have a nice day, and let me know what you think. Yes, I specifically made this harder and longer than the test. No, you can show.